So in this section, we are going to solve systems of inequalities. We've done systems of equations. Now we're going to apply the same thing to inequalities. But first, I want to review graphing lines because you may have forgotten. All right, there are two ways to graph lines. We can either solve for y and use y equals mx plus b, or we can do intercepts. So I'll do it both ways, and you can pick whatever you prefer. So if I solve it for y, I'm going to add 3x to both sides. So I get 4y is 3x plus 12. And then I'm just going to divide by 4 on each. And I'm going to do it with each piece. So that now I have a slope and I have my y-intercept. All right, so let's go ahead and put that on there. Here's my y-intercept at 3, and then my slope, I'm going to go up 1, 2, 3, and over 1, 2, 3, 4. So I put a dot there. I could go down 3, but then I would have to go to the left for it to stay on the same line, right? So there is my line. Okay, now with the intercepts, remember all you're going to do is take each one. If I wanted to solve for, that's a y, sorry. If I wanted to solve for y, find the y-intercept, I'm basically going to just cover up my x. And I would have 4y is 12 left, equals 12. And that gives me y equals 3, my y-intercept. And notice that's where it is. And then if I, hold on, sorry about that. Let's do that again. Right there. Okay. And then I could, instead of solving for my y, now this time I'm going to solve for x. So I'm going to cover up my y, and I'll have, minus 3x is 12. When I divide by -3, I get a -4, and notice that's where that point is. So either way, whether I do it using intercepts or whether I do it solving it for y, I'm going to get the same line, okay? Now, remember when we solve inequalities, we are going to be shading things. Remember when y was less than a function, we shaded below that graph. When y is greater than, we're going to shade above. But sometimes that gets confusing, especially when your line is like, really sharp. What's above and what's below. So method number 2 is the one I use a lot. And that's where you grab just a test point and you plug it into your equation. And if you get something that's true, so that means it's true, if it satisfies it, then you're going to shade on the same side as that test point. If you get it and it's false, so it does not satisfy it, then you're going to shade on the other side of that graph. So let's work one. So, but before I do, let me remind you, if it has an equal mark, remember that means it's going to be a solid line. If it doesn't have an equal mark, it's going to be a dotted or dashed line. And then, again, if it's a less than symbol, then you're going to shade below as long as the y is on the left-hand side. If it's greater than, you're going to shade above. Or you use that test point. So you pick an x and a y and you plug it in. And if it's true, you shade where the point is. And if it's false, you shade on the other side. So, again, let's try this. This is actually the exact same line that I just graphed. So I'm going to go where remember my y-intercept was 3, my x-intercept was -4, so there's my line, but it's not equal, right? Notice that this says is not an equal mark, so it looks like that. So that means I'm going to put it's going to be a dashed line because it doesn't have an equal mark. Right. Now let's grab a test point. And you can grab any point as long as it's not on that dashed line. I love to put in 0, 0 because that's the easiest. So I'm going to plug it in. 4 times 0 minus 3 times 0 is greater than 12. 0 minus 0 is bigger than 12. Is 0 bigger than 12? Nope. That's false. So that means that where that point is, this whole side is not a solution. So it's going to be on the other side. So I'm going to shade on this side. So that's how we graph an inequality. So a system of equations is where we have two of them, and we're going to see where those guys cross. Okay? But let's graph one more inequality, just to show you that it doesn't have to be a line. Okay? So notice this one has a squared. So that means it's going to be a u. So I'm going to go ahead and put my little u dots for my parent function, blast from the past. All right, and then I'm going to move these to the, whoops, not to the left. We're going to move it to the right 2 and up 1. So each one of these, I'm going to go right 2 and up 1, right 2 and up 1, right 2, up 1. 2, up 1, and I'm going to connect them. Again, I do not have an equal mark here, so I'm going to make it dashed. And now I'm going to grab a point. I can use 0, 0 again, because the line or the parabola is not going through there. So I've got 0 is less than 0 minus 2 squared plus 1. So I'm just plugging it right in for my x and my y. So I have 0 is less than negative 2 squared plus 1. So 0 is less than, what, 5? And that's true. 0 is less than 5. So that means that wherever that point is, that's where I'm going to shade. So I'm going to shade through that point, and basically everything on the outside of that parabola, even wrapping around here. Okay. Now, if that symbol had been, if that had been greater than, then I would have shaded all in here. Okay. All right. So now we're going to do systems of inequalities. So for your system of inequality, again, the solution set of a system of inequality is the intersection of the solution sets. So basically, it's going to be where they're both shaded. So let's just work one so that you can see what we're talking about. Let's look this first one. Notice it has a squared. So that's also, I'm going to rewrite it so that it looks more like what we're used to. See, I put my x squared first, negative x squared first. So let's graph that one. Notice that this negative means we're going to flip it, and the 4 means it's going to go up 4. So I'm going to take my dots that were here, right? There they are. I'm going to flip them over. 1, 2, 3, 4, down here. All right. And then I'm going to move them up. So I'm going to erase those guys. I'm going to move all those up 4 places. So let's see, this one goes up 4. And again, I'm doing this relationally. And I'm doing it pretty quick because we have graphed parabolas so much. Now, so there's my dots. I need to connect with, this is a less than sign, right? Not an equal mark. So again, it's going to be dashed. So let's pick a point and see if we're going to shade, where we're going to shade. Okay. Again, I'm going to do 0, 0. So let's put in 0, 0 here and here. So 0 is less than negative 0 squared plus 4. So is 0 less than 4? It is. So I'm going to shade where that dot is, which is inside my parabola. Okay. And now let's graph this next one. The next one is, that looks like a line. I'm going to add 1 on both sides. So I'll get x plus 1 is less than y. Where's my slope? Here's my slope, 1 over 1. So there's my slope. There's my y-intercept. So I'm going to start at 1. And then I'm going to go up 1 and right 1 and up 1 and right 1. So there we go. And I'm going to make that a dotted line because it didn't have an equal mark. I'm going to, you know what? I always grab 0, 0, but just to show you that I don't have to have 0, 0, let me grab another number. Let's try 5, 5, 0. How about that? 5, 0. So 5, 0 would be my point. So where the x is, I would put a 5 in. So it'd be 5 plus 1 is less than 0. So is 6 less than 0? Nope. So that means where this point is, that whole side is not the solution, which means the other side is the solution. So let's shade it up here. Now, my final solution to this whole system is where those guys, the shading, that it's both blue and pink. So that's going to be right in here. So any of these points, anything in there, would be a solution to that system. Now notice that the corners all around the edges, are the edges included? See how they're dotted? So let's make sure I show that these are dotted. So that means that the points on the edge don't work, right? Because it's dotted. Okay. We've got one left. Okay, one more to do. I want to look at this first one because it is definitely odd. We've never seen something like that. This is the absolute value, but notice it's of the y value. Okay, it's not absolute value. We don't even have an x value. Okay, so this says that every y has to be less than 1. Every y has to be less than 1. So that's what this says. Absolute value of y has to be less than or equal to 1. So it's got an equal mark, so I'm going to draw a line here at 1. Okay, so it has to be less than or equal to. So that's going to be below. Now don't draw this. If you're drawing as I'm drawing, don't draw this one yet. Okay, but I'm going to be erasing some of this. So it's going to be all below, okay? So that takes care of when that y is positive. But now I could have a negative y is less than or equal to 1. Because if I take the absolute value of that negative y, I still get y. So you may have done this before in another math class where you did absolute values and you wrote whatever was in absolute value as a positive and then as a negative. I'm going to solve this one. So I'm going to have y and I'm going to have a negative 1, but this time I had to flip it. Right? I had to flip it. So now, and again, don't fill this in yet. I have to put at negative 1, I'm going to put a solid dot or a solid line because it's solid, because it's got an equal mark. And it's supposed to be greater than negative 1. So I would shade it above. Well, that's going to be like everything, right? That's going to be everything. But it's got to be both of those. Okay, so this says that no matter what number, what y I put in, if I take the absolute value of it, it has to be 1 or less than 1. So I'm going to erase all of that and erase all of that, and let me show you what the shortcut. So I'm going to have where it is 1 and negative 1, and I'm just going to shade everything in between. Because any of those points in there, if I look at the y value and I take the absolute value of it, it's going to be 1 or less than 1. Okay, so think of any point. Now, if I had a point up here, say this point. If the y value is 5, notice it's not less than 1. And this point down here, negative 6. If I take the absolute value of that, that's 6. It's not less than 1. It's only these in here that if I take the absolute value of the y values, it's going to be less than 1. So that's just a neat thing to remember. If I had y absolute value of y is less than, say, 10, then or let's say 5. 5, then it would be 5 and 5, and it would be everything shaded in between. All right, but we've got one. So we've done that one. Now let's go to this, the second one. X is greater than or equal to 0. Well, think of the line x equals 0. Line x equals 0 is right here. Okay, and I made it solid because it has an equal mark, right? Now, it's supposed to be greater than or equal to 0. So the ones that are greater than or equal to 0 would be on this side. Okay, if you don't just automatically know that, that's okay. Just pick a point, right? Just pick any old point. Whatever that is, that looks like 5, -4. And put it in there. Is 5 greater than 0? It is. So I'd shade on that side. All right. Now we have one left. I'll do this one in brown, I guess. All right, I've got one left. Now notice that this is my absolute value. So this is going to be a V. All right, but we have to, what are we going to do to that V? We've got to move it down 4. And we got to stretch it. Okay, so let's go ahead and put my little dots. I'm going to try and make them sort of light so they don't interfere with everything. But we need to stretch it, okay? So remember how we stretched? If this is 1, it's going up just 1. Then we stretch it, and it'll go up 2. So that's going to be like there. There's that and that one. And this one will be at 2. Remember, this guy, this distance is 2. So 2 times 2 is 4. So I will put a little dot here at 4. So now I've got my 4 brown dots. So I've stretched it. Now I'm going to move it down 4. So I'm going to take, if it'll let me, I don't think it will. Can I take that and move it down? Nope. All right. So I'm going to take that middle dot and I'm going to move it down 4. 1, 2, 3, 4. That's going to go right here. And then on the left-hand side, I'm going to go over 1 and up 2. And on the right, over 1 and up 2. And then over 2 and up. How many did we go? 1, 2, 3, 4. 2, 3, 4. All right. And I'm going to connect these with a dashed line. All right. I need to pick a point. I like 0, 0. So I'm going to pick 0, 0, plug it in to this equation. Oops. Let me put that. Let me make that one 0 also. So 0, that's my y, is greater than 2 times the absolute value of 0. That's 0 minus 4. So is 0 bigger than -4? It is. So I'm going to shade where I have the dot. So I'm going to shade inside. All right. So I had to graph all of these first, and now the actual answer is where it's going to be brown, blue, and pink. Brown, blue, and pink. I only see one area where it's brown, blue, and pink. That is, here's in between the blues, and it's pink, and it's brown. So that's just this little sort of polygon right there, right? And then the outsides, make it, let's see, this one is solid, and this one is solid. This one is dotted, and this one is solid. So that's the end of 9.6.